Alright, what's up mga Chimek? So, we're down to the part 2 of our problem solving. We have answered the first 4 problems already, so we're going to answer items number 5, 6, 7, and 8 now for your reference and for your review for tomorrow's exam. So, without further ado, for number 5, a weather balloon is filled with helium to a volume of 275 liters at 22 degrees Celsius and 752 millimeter in mercury. The balloon ascends to an altitude where the pressure is 480 millimeter Hg and the temperature is 32 degrees Celsius. What is the volume of the balloon at this altitude? Now, as I would usually say to you, we would, if it's difficult for you to understand the problem, I think an illustration of what is happening might help you to solve your particular problem. So if it's already in your imagination, then don't bother, because it would take time. But to better understand, let's have an illustration. So we have a balloon on the ground. Don't think of anything else. It's a helium balloon. If you can imagine balloons during Peña Francia and Christmas or Fiesta, yung mga floating balloons, animals. Why are they floating? It's because it's filled with helium. That's why it's a bit expensive, 75 to 100 pesos. Because the helium makes it float. So at the ground, sabi dito, a volume of a particular balloon is 275 liters. So that's quite a big balloon. That's your initial volume. And then your temperature at the ground is 22 degrees Celsius. So we are assuming it's around December, malamig, and gabi, maulan, 22 degrees Celsius. That's why that's the temperature. And then the pressure is 752 mmHg, millimeter in mercury. So 752 mmHg. And then suddenly, umiyak yung bata. Tapos tayo tumawa at nagbabay sa langit. Bakit? Lumipad yung lobo, sayang ng pera ko, sa pagkain sana nabusog pa ako. The balloon ascends. So lagay natin dito, kunwari ito na yung after. Lumipad sa langit. Pero nakita pa rin natin. It ascends in a particular altitude where the pressure now, so the pressure relatively dropped, from 752 it becomes 480 mmHg, millimeters in mercury. This is one way of measuring the pressure. And then the temperature increased, due to convection current, warm air goes up. So these are now the combination of all the sciences, our earth science. Warm air will go up. That's why sa taas medyo mas mainit. It's 10 degrees more hot, or 10 degrees hotter rather, above. So what would be the new volume? So obviously, since the pressure and temperature changed, the volume will change. Now, let me ask you before we proceed any further, what do you think will happen to the volume of the balloon? Will it increase or will it decrease? Alright, hold on for your answer for quite a moment. So this is the illustration, and this is the given already. Again, if you master already the understanding of the comprehension of the problem, you might skip this part. You might want to skip this part to save time. It took me 2 minutes just to illustrate and to write while explaining. Nonetheless, this might help you. So, next step, usually, common mistake ng students dito, magsusolve na agad sila kasi alam na nila yung equation, kasi nakita na yung mga given. But again, to avoid mistakes, to avoid errors in your computation, make sure that the units are written in their appropriate format. Say for instance, your temperature is in degrees Celsius, it should be in Kelvin, and our pressure should be in ATM. Now, don't you worry in the exam kasi given naman yung values in ATM. If not, the conversion unit will be given right in the item of the exam. So here, 1 ATM is equals to 752 mmHg. So I'll be translating 752 mmHg to ATM. So that's 752 over, where's my Desmos? Yan, 752 over 760. So that's roughly 0.98 or 0.99. No, 752, but let's divide to check. 760. Alright, that's 0.98, but significant figures is dalawa lang, 76. So we can round it up to 0.99. So I'll be using 0.99 ATM for my initial pressure. Alright, and then dito sa final pressure 480. So let me just change this value 480. I don't know if you can see the numerics here, but if not, you can follow with your calculator. So that would give me 0.63. Now 1.5, so that's 0.63. Two significant figures as well. 0.63. Kasi dito, two significant figures lang din. Alright. ATM. And then, I'll change my degrees Celsius to Kelvin by adding 273. Sorry for the penmanship, even in the digital way. 32 plus 273. That's 295. Yes. Tama ba? 305 brother. Sorry. 305. 32 plus 273. Yeah, that's right. That's 305 Kelvin. 305 Kelvin. And then 22 degrees Celsius plus 273. That's 295 Kelvin. Alright, 295 Kelvin. There you have it. Now, in proper units already, our volume is in liter, so it's good to go. No. Now, the next step is to determine what equation to use. And again, you can memorize all the gas loss equation, or you can simply look at your Codigo. You can search it in the internet, but we are after your skill. No? What if after the pandemic there's no more internet? So what do you think that can help? Where will you rely to? It should be in your brain. So again, in chemistry, we don't memorize. No, we understand. Because if you study to remember, you will forget. But if you study to understand, you will remember. Alright, that's an adage from a very long time ago. So you just have to remember one of the most elegant equations in the universe. No? The PV is equals to nRD, the ideal gas equation. And then, out of this, diba, this is a repetition. Sir, ulit-ulit ka na umay, diba? But repetition will make you master the concept. So isolate the given PTV, PTV. So just divide both sides by T. Then cancel, cancel. All the givens are on the other side. You don't need this. So you mirror what's in the left side to the right side. Alright. Mirroring, assign the initials and the finals for the factors that are involved. Alright, let me full screen this one para mas makita natin. And then I'm looking for the final volume, no, of the balloon when it ascends at a specific altitude. So let me manipulate the equation by removing the denominators first. Multiply it both sides by T1, T2. T1, T2. Pwede naman T2 lang. So whatever makes you comfortable, kasi sometimes we hate dividing a fraction with another fraction. So better pag nakaganito lang. So that would be T2, P1, V1. Hopefully you can follow. P2, V2, T1. I just need the V2, so I divide again both sides by P2, V1, so that, sorry, this is V1, nadadala ng aking mouse, P2, V1. So later on, iba na, yung gamitin ko na lang yung pen touch. Cancel, cancel. Alright, so let me rewrite that so that it would be cleaner, more clean. Rather, that's P2 is equals to T2, P1, V1, P2, V1. Alright, I think there's, this is V2. Sige, V2. Tama ba? Joke. This is P2. This is 1. Sige, pati ako nalito sa sulat ko. This is P2 kasi dinivide ko pala both sides ng P2, V2. So, P2 is equals to V2 pala to. V2 pati ako nalito. V2 is equals to T2 P1 V1 over P2 V2. Alright? So, we manipulated the equation. Let me write it here para mas malinaw. So, V2 is equals to, we substitute now the values. Our final temperature is 305 Kelvin. So, 305 Kelvin. And then, our initial pressure is 0.9 atm, 0.99 atm. And then, the initial volume is 275 liters. So, 275 liters. And, ayan, that would be divided to P2 V2, which is 0.63 atm. And then, this is not V2 kasi yun yung hinahanap natin. T2, eto T2. Yan, T2. Sige, kasi dinivide natin. This is T1 rather, T1. Sige, sorry for the confusion. This is T1. Alright, P2, T1 kasi galing dito. So this is P2 and then T1. So the T1 or the initial temperature is 295 Kelvin. Sige, if you're confused dito, pwede natin ma-check if we are getting the right equation. Now, by canceling the units already. So Kelvin, numerator, denominator, and I'll be left with liters. So this is good. This is correct. Now, all I need to do is input it in my calculator. 305 times 0.99 times 2.75. So hopefully I've memorized that. 305 times 0.99 times 275. Tama ba? Sana. Oo, tama. 275. 0.63295. Then 0.63 times 295. And that would give me 446.79. 446.79 liters. Is this my final answer? Obviously not. No, it should be in the proper significant figures. Now let's count. We have 1, 2, 3. 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. Now remember, if you already forgot, ito lang naman tatandaan natin sa gas laws because we are just merely multiplying and dividing. When multiplying and dividing, no, we need to follow the least significant figures in the equation. So here, we have two significant figures, and that's the least significant figure. So we need to transform this into two significant figures because it is in 5 significant figures. So in order to do that, that would be converted into 1 to 44, should be 450 liters. Now that's two significant figures. You can also write it in terms of power, no, in power of 10, that would be 4.5 times 2 liters. So 2 significant figures. But both of these are the correct answer, no? Correct final answer. So this is the final volume. So if you answered a while ago that the volume would increase because the temperature increased, voila, you're correct. No? From 275 liters, it becomes 450 liters. Now let's proceed to the 6th problem. Alright, for item number 6, it gets a little more complicated, you know. But again, just be calm in answering such problems. So how many moles of methane gas, CH4, are in 1.00 times 105 liter storage? No, I think this should be 10 raised to 5 liters. But since it's the given, no, we have to stick with it. At STP, how many grams of methane is this? How many grams of carbon dioxide gas could the same tank hold? Now, I think it might be really confusing and challenging seeing that there's seemingly only one given. But again, as I've mentioned, no, there's a lot more in the problem if you understand the concept of the gas laws. Specifically, here in the ideal gas law. So let's write first the given here, which is 1.00 times 105 liters. So we can just simply write 105 liters. That is your 105 liters. No, and then there's nothing else, no, except for the fact that it has been mentioned here that it's in STP, no, meaning standard temperature and pressure. And we learned that, if you've been watching the video, that at STP, this is your 105 liters methane, no, at STP, the temperature is 0 degrees Celsius or 273 Kelvin, pressure is 180 m, and the 1 mole of any gas is 22 liters, no, 22.4 liters, will occupy 22.4 liters. Since it is an STP, we assume that the temperature is 273 Kelvin and then the pressure is 180 m, and we will assume that out of this entire liters, no, the mole of CH4, so the CH4, this is the methane, no, the number of moles of CH4 will be 1 mole every 22.4 liters. And to convert that, to get the mole, no, to get N, we are looking for N, it is simply 105 liters times the values at STP. So 1 mole per, there's 1 mole in every 22.4 liters, so that the liters will cancel out. So 105 times 1 divided by 22.4. So let me use the Desmos here. So 105 divided by 22.4, that would give me 4.6875. Now 4.6875, 4.6875 moles. Significant figures 1, 2, 3, 1, 2, 3. Hindi na to sinasali kasi it's just a converting unit. So 1, 2, 3, 1, 2, 3, that is 4.69 moles of CH4 or methane gas. So we answered the first problem, no, the N, sorry for the box, it's not a box, it's a crater. Okay, the N is, or the moles of methane gas is 4.69. Yan. Then how many grams of methane is this? So we want to know how heavy this methane gas is. And since methane is a compound, so don't worry, we just have to weigh it using their individual molar masses. So we have 1 carbon. 1 carbon is 12.01. So again, I don't care if what you will use, if what is in your periodic table. Some is 12 lang, some is 12.1, some is meron pang extended values. As long as what you do is proper, no. Ang magbabago lang naman dyan, decimal places. So H is 1.00 something. So maybe you can use 1, no, if you want. However, you have 4. So dito you only have 1 carbon. Saan galing to? You have CH4. So that's times 4. That would be 12 grams per mole. It's the molar mass in the periodic table. So you can see that there. So 1, this becomes 4 grams per mole. And this becomes 16 grams per mole. So this is the molar mass of the entire methane. Now we are just looking for the weight, no, of the methane itself. So we need to cancel the mole and we'll be using this one. So this becomes now 16 grams per mole. Yan. Multiplied, so let me rewrite that, 16 grams per mole multiplied to 4.69 mole, so that the mole will cancel out. So meaning lang naman nito, for every mole ng CH4, it weighs 16 grams. So, since you have 4.69 moles ng methane, you have to multiply it to 16 grams. So, that is 16 times 4.69. 16 times 4.69. That would give you 75.04. This will give you 75.04 grams. Now, however, you have 1 to 2 significant figures. This is just 75 grams. So, this is the weight of your methane gas. Now, finally, hopefully you can still follow. Now, how many grams of carbon dioxide gas could the same tank hold? So, we have carbon dioxide, CO2. So, grams din ang hinahanap. So, back to square one tayo. So, we'll be using the same mole kasi di naman sinabing nagbago yung volume. However, we have to calculate the molar mass of the carbon dioxide. So, carbon is 12.01 times 1. That would be 12.01 grams per mole. Oxygen is 2, so that would be 16 point something. I don't have a periodic table with me, so I decided to use 16. That's fine. No, we are really after the process. That would be 32 grams per mole. So 12.01 32, that would be 44. Tama ba? Yes, 0.01 grams per mole. Alright, and then to get this one, no, we just copy what we did a while ago. 44.01 of mole, grams per mole. This is your carbon dioxide times 4.69 moles, since di naman nagbago ang liters natin. So that would be 44. Moles will cancel. Where's the cursor now? Here. Moles will cancel. 44.01 44.01 times 4.69. That would be 206.41. 206.41. We have three significant figures, so we just write 206. 206 grams. So, meaning, the carbon dioxide would be heavier than the methane given the same situation, given the same volume. Alright? So, that's just the the application of moles and then the gas law. So, this is the combination. Hopefully, you get it. Alright. Let's proceed to number 7. Number 7. Sige, let me just... Yan. Number 7, let's read the problem. An aerosol spray can of deodorant, let's say an Axe spray, with a volume of 350 milliliter contains 3.2 grams of propane gas as propellant. What is the pressure in the can at 20 degrees Celsius? So let's write first the given. We have volume 350 ml. The volume is 350 ml, and then we have the weight, no, which is, what was that, 3.2 grams. 3.2 grams. And then the temperature is 20 degrees Celsius. 20 degrees Celsius. We are looking for the pressure. So we are missing N, we are missing N, and we are missing the pressure. So in order to do that, now we cannot get the pressure using the grams, but we can get the moles using this one. How is that? No, we identify the elements composing the propane. That's C3H8. So guys, similar sa ginawa natin kanina, C3H8. No, we just write their molar masses, respective molar masses. Carbon is 12.01 grams per mole. Oxygen, I think, is 1.0001 something. So I can just write 1 grams per mole. However, I have 3 carbon, I have 8 hydrogen, this is propane. On the Gen Chem 2, we will learn how to name alkanes and alkynes. That is 12 times 3, 12, 24, 36, 36.03 grams per mole. And then here I have 8 grams per mole. I copy the unit, that is 0.03 grams per mole. 0.36 plus 8, that is 4, carry 1, 44. 44.03 grams per mole. Now, how do I get N? Paano natin makukuha si N? 44.03 grams per mole. Alright, how do we get the mole? And there you have it. Since we have 3.2 grams, 3.2 grams, we need a conversion unit where the grams would be at the denominator. So it would be 44.03 grams per mole. Grams will cancel out. And yan, pag nalilito ka kung tama ba ang ginagawa mo, i-check mo lang. Ang meaning lang naman nito, ang isang mole mo, meaning where N is 1, when N is 1, it should be 44.03 grams. Now, since you have a 3.2 grams na given, it simply means that your N should be less than 1. Very less than 1. And in order to attain that, you should have a numerator which is lesser than your denominator. Hopefully, you get that. So that is 3.3 grams times 1 mole over 44.03. So that would give us 3.2 over 44.03 moles. Alright. So 3.2 divided by 44.3, 3.2 divided by 44.3, that gives us 0.07223. Sorry medyo karalat-kalat ang ating penmanship. 0.07223 moles of propane gas, of C3H8 if you want to complete your answer. That would be 1, 2, 1, 2, 3. So 2 significant figures. So that is just 0.07. Significant figures ba ang leading zeros? I think not. No? So, check nyo na lang. Kindly comment na, sir, mali ka. Significant figures po ito. Leading. I am confused as well. Basta, zeros after are not. So, kung leading zeros is significant, 1 to 0.7 lang siya. 0.07 rather. Kung hindi, 0.072 moles. So, this is your final answer for the N. No, this is just the excuse me. This is just the N. Sorry, dust. And then, since we already got the N, since we already got the N, now we can now use the equation, which is, so i-write muna natin dito ang N, 0.072. The PV and RT, since there's no initial and final value, it's just a single equation. So we are looking for the pressure. So we need to isolate the pressure. We divide both sides by P, or by V rather, by V. So I'll be left with P is equals to nRT V. Alright, and then dito na natin para buwelo. I'll substitute now the value. My N is 0.072 moles times my R. No, if you can remember R, that's 0.0821 mole that Kelvin over ATM that liter. Now, if you're unsure of the unit, pwede nyo naman tong i-manipulate. Sige, check natin. PV and RT. If I isolate R, that would be R is equals to PV over NT. The pressure, ATM, and the volume should be at the top. So, meaning, mali ako. Now, I have to erase this one. Sige, erase. This is a good way to check if your unit is correct. So, by manipulating PV and RT, you can check the unit. PV, tama ba? Over NT to get R. So, that should be pressure is ATM. So, ATM dot liter mole dot Kelvin. So, na-interchange ko. Mole dot Kelvin. Ano yung gamit ko kanina? It's a brush, I think. Brush ba yun? Anyways, yan. And then, multiplied. Sorry, wala nang space dito. So, we still multiply it. Times ko na lang. By the temperature, 20 degrees Celsius. We forgot to change it to Kelvin. That is 293 Kelvin. So, 293 Kelvin over the volume, which is 350 ml, and we forgot to convert it to liters. So 350 ml over 1000 ml, that's your milliliter, that's 0.35 liters. So 0.35 liters. Let's cancel the unit first. Mole will cancel, and then Kelvin will cancel as well. Liter will cancel, and we'll be left with ATM. Now the rest is up to you, no? You input it to calculator. Sige, let's input here, or 0.072 times 0.0821 0.0821 times 293 Kelvin 293 Kelvin divided by let's go back. So, yan. Para hindi mamali, 1.731 divided by 0.35. 1.7319. 1.7319 divided by 0.35. 0.35. Bakit naging ganon? Ala. 1 point, ano nga yan? 7319. Tama ba? Divided by 0.35. So anyways, if mali man ang makuha ko, bakit nagpupunta siya dito? At least, the process, no? Kung mali ito, 1.73. That is 4.9685. Sige, 4.9685. 4.9685. Significant figures, no? List significant figures when multiplying and dividing. ATM. That is 1, 2, 1, 2, 3, 1, 2. Two significant figures. So, we change it to 4.9. Alright? Or, it could be, since 6 dito, it could be 5.0 ATM. No? The more appropriate answer is this one. No? 5.0 ATM. Kasi we look at the next number, we round it up, so it becomes 0 and then 5. 5.0 ATM with two significant figures. And that is the final answer. Sige, check ko nga para baka mamali tuloy yung sagot. 0.072 times ulit natin. 0.072 times 0.0821 times 293. Tama, 1.73. Alright? So, that's the answer for number 7. And for the last item, a helium gas cylinder of the sort used to fill balloons as a volume of 180 liters at a pressure of, then how many moles? Okay, I think this is a bit easy now as compared to the last two problems we solved. So let's write first the given. Volume 180, pressure 150 ATM. volume is 150 liters. Pressure, just kidding, baliktad, 180. Volume is 180 liters. Pressure is 150 atm. Alright, pressure is 150 atm. And then, temperature is 25 degrees Celsius. Temperature is 25 degrees Celsius. What is the number of moles of helium in the tank? So, the N of HE is what we are looking at. So, again, there's no initial and final whatsoever. So, this is just your typical PV is nRT. Looking for N, we manipulate by isolating N. We'll get N is equals to PV is equals to RT. We substitute the given values. We transform first this to Kelvin. 25 plus 273, that is 298 Kelvin. Alright, the pressure is in ATM already, 150 ATM, multiplied to volume, which is 180 liters, divided by R, which is 0.0821, and then ano nga yung R, ATM dot liter times mole dot Kelvin, and then multiplied to 98 Kelvin. Alright, cancel the units, LL, ATM, ATM, AK will be left with mole, and there you have it. N, simply input it into your calculator. Thank you, Desmos. 150 times 180, that's 27,000. So let's rewrite that. 27,000 divided by 0.0821. Bakit nagaganito? 0.0821 times 298. 298. That would be 1103. 1103. The number of moles is 1103.58. 58 moles. It's a lot of gas. However, the significant figures is 1, 2, 3, 1, 2, 1, 2, 1, 2, 3. So the least number is 2. So we convert it into two significant figures. That would be 1,100 moles. So N is equals to 1,000. Two significant figures. Alright. 1,100 moles. Or you can write it by 1.1 times 10 raised to 2 moles. That's accepted as well. Alright? That is your N. However, we still have another question here. How many in grams? So, since we are asked for the grams, we have to write the molar mass of helium. Helium's molar mass is, I don't know. So, we search or we look at the periodic table. Helium's molar mass. And there you have it. And while waiting, yan, that is 4. No? Sabihin na lang natin 4 kasi there's a lot of 0 there. 4 grams per mole. Alright, so 4 grams per mole. To get the grams, no, that's just 4 grams times. So, meaning lang nito, for every mole, there's 4 grams. The weight is 4 grams. So, we have here 110 moles per gram. Cancel, cancel. That would be 4,400. Ay, mali. moles pa lang inaanap natin. Sige, baka malito kayo. Erase natin to. Erase. Sige, we're looking for the grams. Sige, grams. So, it's 4 grams. Dapat ito ang nandito. 4 grams per mole. And we have 1100 mole. Moles will cancel. That's 100 times 4 grams. That is 4,400 grams. So, the mass, the molar mass, no, at this given digits would be 4,400 grams of helium gas. Alright, there you have it. If you have any questions with regards to gas laws, don't hesitate to comment. If you notice that there's something wrong in what we have solved, please correct me, no, that is a way of learning too, no. The learning is always a two-way process. Thank you so much, and God bless to your exam, and yan, Merry Christmas, no. Let's see each other again next semester if I'm still your teacher. Peace out. Thank you, mga kachimek, no. Merry Christmas and a happy New Year. Bye-bye.